What is it that astronomers have found using our new $10 billion toy? It will be years before that project becomes a reality. If it goes as planned, the journey to Proxima will take about 20 years, so realistically, it will be several decades before we can confirm if there is indeed life on that planet. The age-old question, are we truly alone in this universe? The James Webb Space Telescope has discovered some terrifyingly human-esque things far, far away from Earth that lead us closer to the answer. Our search for life outside of us has been rampant throughout each human civilization, so much so that we have thousands and thousands of media, literature, and theories on this subject. Our wonder regarding our place and loneliness in the universe has been constant, as if it is ingrained inside of us to always search for a companion no matter how alien-like. We just might be getting closer and closer to the answers we truly want, but are they truly the answers we are looking for, or are they much more terrifying? Join us as we explore the latest discovery in the realms of galaxies and planets on the quest to find something we just might not be prepared to witness. Lights far, far, far away, scientists have discovered what could be the most groundbreaking discovery in history. Back in 2021, when the James Webb Space Telescope was scheduled to launch, a very interesting hypothetical question was raised about the capabilities of our technology. The question was whether, in the future, our telescopes could detect artificial light on another planet, for example, Proxima b, the closest exoplanet to Earth. Proxima b, about 4.25 light-years away, was believed to be tidally locked with a permanent day side and night side similar to our moon. A hypothetical technological civilization on Proxima b might transfer heat and electricity from the day side to the night side using photovoltaic cells that generate electricity out of starlight. Subsequently, in a paper with Manasvi Lingam as one of the researchers, it was shown that significant coverage of the day side by solar panels could be detected with future telescopes. Since JWST was more advanced, it would allow us to extend our search for artificial lights to habitable exoplanets like Proxima b. Now, in 2024, it is possible that the James Webb Space Telescope did just that. Using its higher sensitivity and bigger range of capabilities, the JWST might have discovered the lights we were looking for and possibly hurled us into another big surge of human evolution. But first, let us dive into the world of planets and exoplanets to learn how all this was even possible. James Webb's mission explores Proxima Centauri b's secrets. Throughout history, humans have wondered about the nature of the universe, what we are, where we come from, and where we go. These are common yet extremely difficult questions man has tried to answer as soon as he gained consciousness. Now, in the age of exponential technological advancement, one does wonder if we are any closer to any of the above questions. If you would ask a philosopher, he would probably say we are still at level 0 of understanding ourselves in the universe. However, ask an astronomer the same thing and watch him jump up and down in excitement as he rushes to tell you the latest discovery humans made about the universe using their nifty tools. These tools, although not paid much attention to by the average public, are quite literally a manifestation of human evolution itself. We now have the world at our fingertips, and it is time we move forward and get the universe at our fingertips as well. One such way to do that has been deduced by scientists and astronomers. It is through the technology we harness. A specific creation of that said technology is now responsible for the recent discovery of what might be light on a different planet, light years away. Yes, we're talking about the James Webb Space Telescope. The James Webb Space Telescope is the creation born out of the legacies of human expeditions into space to answer some ever-present questions. Are we alone? Who's out there? Where do we begin? And where do we end? Well, this infrared astronomy tool has already begun answering these questions, although partially. First, you might find yourself asking what even is Proxima b? Proxima Centauri b, or just Proxima b, is sometimes referred to as Alpha Centauri Cb. It is a super-Earth exoplanet that orbits an M-type star. Super-Earth exoplanets, confused yet? Do not worry, since this video will quell all of your burning questions. Super-Earths are a class of planets that are more massive than Earth yet lighter than ice giants like Neptune and Uranus. They are truly one of a kind. They can be made up of gas, rock, or even a combination of both, and their sizes can vary from twice the size of Earth all the way to 10 times its mass. They really put the super in super-Earth, huh? As for Proxima b, it is a super-Earth and an exoplanet, meaning that it is a planet that traverses outside the solar system. The very first possible evidence of an exoplanet was found in 1977, although it managed to stir up little curiosity and recognition. However, in 1992, the first confirmed detection occurred, which left scientists speechless. Another exoplanet, a different one, which was first detected in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Out of them, 896 systems had more than one planet. These marvelous discoveries are orbiting an M-type star right now. To explain the M-type star, you need to understand the red dwarf. A red dwarf is the smallest kind of star in the main sequence, hence the name. In the neighboring regions of the Sun, red dwarfs are by far the most common type of star to be found in the Milky Way. They have really low luminosity, and since luminosity is one of our main tools for planet detection and other types of deductions, red dwarfs are not that easy to observe. The sneaky stars have variable definitions and names depending on their temperatures and sizes. For example, M dwarfs, or M-type main sequence stars, yield a maximum temperature of 3000 K, hence getting their name and attributes. Coming back to Proxima b, its mass is known to be equivalent to 1.07 Earths. Interestingly, it only takes 11.2 days to complete one orbit of its star, compared to our 365.2 days. You can estimate the size of the star Proxima b is orbiting. Staggeringly, under the measurement of the entire electromagnetic spectrum, the star has a total luminosity of only about 1.6% that of the Sun. Additionally, in the visible light spectrum, its luminosity seems to dull even more as it appears fainter. It only illuminates 5 to 6% of the Sun's luminosity in the visible light spectrum, emitting a significantly less amount of light energy when compared to the Sun. Over 85% of its emitted energy is in the form of infrared radiation. Orbiting about 0.045 to 0.056 astronomical units away from its star, Proxima b's discovery was announced way back in 2016. You might be wondering, why Proxima b? With millions of stars, planets, and galaxies, why are we so fixated on this particular celestial body? Well, there are a few reasons that contribute to the keen interest astronomers have in this place. First and foremost, Proxima b is the closest known star to our Sun, and by definition, although 4.2 light-years is a big number to us Earthlings, in the grand scheme of the universe, it is a mere blip. Hence, Proxima b, our closest known star, is high up on the priority list at the moment. It is also part of the triple star system called Alpha Centauri. Although Proxima's luminosity is very low, the system itself appears as one of the brightest constellations in the night sky, only behind two others called Sirius and Canopus. However, the most interesting thing about Proxima Centauri b is that it might potentially be habitable, since it falls under the habitable zone. The possibilities surrounding the star are endless, and thus astronomers have taken on the expedition to explore the depths and limits of the potential of the star. That is where the James Webb Space Telescope comes in. The 4 key goals of the JWST are to search for light from the first stars and galaxies that formed in the universe after the Big Bang, study galaxy formation and evolution, understand star and planet formation, and study planetary systems and the origins of life. As the JWST continues its exploration of the said exoplanet, we get closer and closer to the completion of these missions. From SETI to exoplanets, searching for alien life, what exactly is SETI, one might ask? Considering that humans have always been a curious species, poking and prodding into literally anything and everything that moves and doesn't move, it makes sense that a quest like SETI came into existence on such a large scale. Imagine that God has organized a grand cosmic treasure hunt, but with a twist. Instead of gold, we are tasked to be on the lookout for signals, more specifically electromagnetic whispers from civilizations beyond our wildest dreams. SETI is short for the search for extraterrestrial intelligence. It is like the world's most high-stakes game of hide and seek, with our planet as the seeker and the vast universe as the seemingly infinite hiding spot. It is one of those fields where scientists are modern-day Sherlocks, tuned into radio waves and scouring for that elusive "we are not alone" moment. This game of cosmic eavesdropping began in earnest in the 1960s. Frank Drake, a man who could make even Einstein say, "Now that's a smart cookie," pointed a radio telescope at two sun-like stars and listened. Although he was greeted with the sound of silence, Drake's equation, an algebraic recipe to estimate the number of civilizations in our galaxy, set the stage for generations to come. Fast forward to now, and SETI has turned from a backyard science project into an interstellar endeavor. Scientists use an array of tools, from the giant Arecibo telescope to the Allen telescope array, a network of dishes that looks like a high-tech crop circle. The aim is to catch that one peculiar signal, a blip or a whisper that says hello from another world. These are radio signals that SETI typically hunts for, the kind that you might hear on your FM dial, just with a touch more stardust. But in 1977, a signal named "Wow" was received. It was a radio burst so distinct that it made the astronomer who found it write "Wow" in the margins of the data printout. Was it ET phoning home? Not quite clear, but it fueled the fervor to keep the ears of our giant dishes open.